Okay, so practicing box plots. So first off, for number 1, we are asked to create a box plot to represent the heights of a randomly chosen group of freshman students. So our values are already in least to greatest order. So I'm going to go ahead and find my values here. So the minimum value is 57. The maximum value is 72. Maximum here is 72. In the middle, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 values. So I'm going to need to go to the 2 middle numbers and take an average of those. So 63 and 64, the average of that is 63.5. Okay. And then our midpoint here, 1, 2, 3, 4, 5, 6, 7, 8, I have 8 values again. So my 2 middle numbers are both a 60 on my, between my lower quartile here. So my midpoint here is going to be a 60. And then above that, I have 65 and 67. And of course the average of that is 66. So here are my 5 values that I'm going to be working with. Alright, so I'm going to go ahead and create my number line. And I'm going to go 50, 55, 60, 65, 70, and 75. And I'm going to put some lines in between here. And of course you want these to be as precise as possible. But it does happen occasionally that, if you're drawing out your number line, it's going to be a little bit less precise, just because it's human error. But if you have a number line given to you, that's even better. Alright, so let's start by plotting our points. So we have 57, so here's a point, 60, here's that point, 63.5 is right here, 66, make these a little bit darker, and 72. Okay, so there's my values. I'm going to put my box around my quartiles and my vertical line in the median, and then I'm going to put in my horizontal lines. Okay, and so there is my box plot. Alright, now the second question asks us to do the same thing, and it asks us to use the same number line as question 1 so that we can do a comparison. So that means I need to find my values. So 58 is my lowest number, my maximum is 76. So again, my middle number here is going to be 65. Yep. And then I have a lower number. 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 15 numbers, yes. And then 1, 2, 3, 4, 5, 6, 7. So my middle number here is going to be 62. And my upper number is going to be 70. Okay. Alright, so I'm going to draw this number line again. And I'm going to go ahead and keep my numbers the same. I have 50, 55, 60, 65, 70, 75, and I do have one number past 75, so I'm actually going to extend this out just a smidge. So I have one number past that to be 76. It doesn't really change my number line very much because I had room there for a 76th spot. I just didn't put it on there. So let me go ahead and draw my numbers. 4, 1, 2, 3, 4, 1, 2, 3, 4. Alright, so let's go ahead and plot these points. I have a 58, I have 62, 65, 70, and 76. Put my box through here, my vertical line, and my whiskers. Right? And so there are my 2 different box plots here. Okay. Alright, so number 3, ask us to use the data that we just created, the 2 box plots that we just created from numbers 1 and 2. So the question is to describe the distribution of the data in each box plot. So if we look, most of my data is kind of right here in the middle, where it's supposed to be, with not really a skew one way or the next. Again, same thing here, right here in the middle with very little skew. If it is skewed any, it's skewed a little bit to the right, so I would say that both box plots are fairly symmetric with a very slight skew to the right. And truthfully, that's just normal. You're not going to have a perfect symmetry most of the time, so I would really call both of these symmetric. Now we're going to compare the median range and interquartile range of each box plot. So the medians, we have a median of 63.5 and 65. So I would say that the median are very similar. That second box plot is really only 1.5 points difference between them. So are very, very similar. The range for these, 72 minus 57, so let's do that quick calculation here. The range here is 15, and the range here is 76 minus 58 is 18, and then the interquartile range is going to be 6 on this one, and interquartile range here is going to be 8. So in both the range and the interquartile are both larger or greater in the second box plot. So the range and interquartile range of the second box plot is higher than the first. Alright, so then another question, do any values in either box plot appear to be an outlier? So are there any values that appear to be a number way out there? So by appearance only, I would say that no values appear to be an outlier. If they were, the 2 maximum values might be. So let's just do a quick calculation here. On the first one, we would do those maximum values. So with our outlier formula, we would take the Q3, so 66, plus 1.5 times the interquartile range, which was 6. And that would give me a value of 75. So a number would have to be greater than 75 here to be an outlier. And then down here, we would have a 70 plus 1.5 times 8. So 70, a value of 82. So I would have to have a value of 75 to be an outlier here and a value of 82. I don't have that for either one of these. And then just to double check our minimum values, we would have 60 minus 1.5 times 6. It would have to be a number lower than 51. We don't have that there. And then here we would have 62 minus 1.5 times 8. And we would have to have a number lower than 50. And we don't have that on either one. So mathematically, we would not have that. So so to prove that theory, we would say that the first box plot would need values less than 51 or greater than 75 to be an outlier. And the second box plot would need values less than 50 and greater than 82, and neither box plot has outliers. Okay, none of those have values outside of those numbers, so no outliers for these questions. All right, now, next section, the last question here. The freshman students claim that they are taller than the seniors, and the seniors claim that they are taller than the freshmen. So what class of students appears to be the taller class? And so here is where you are going to input your opinion and give justification. And so there could be a lot of different answers here. You could look at averages. You could look at medians. You could look at the spread of data to make a decision for the class overall as a whole. So I want you to think about your opinion on that and put a justification there, and use statistics, one of the values that we have discussed, to make that decision. But ultimately, it's an opinion question as long as you justify it.